All right, guys, so welcome back here to a part 2 video of factoring and solving polynomial functions. Okay, so we're still solving equations, and we're going to get into a new type of factoring with some of these other ones over here, but we're going to start with number 1, okay? Still a new type of factoring, but using a similar strategy. Okay, so there's 3 problems, and let's get into it. Okay, so this first one, number 1, x to the 4th power minus 3x squared equals 4. Okay, so for these problems, again, just like the other ones that we looked at, we want to get all the terms on the same side of the, okay, so with 4, okay, with this 4, I want to minus that to the other side, okay, so that this right side says equals 0, okay, but then I have x to the 4th minus 3x squared minus 4 equals 0, okay. So now that is all together on that side, okay, and I would try to factor this, okay. I'll try to factor that into 2 individual groups so that I can solve it using the zero product property like we've done before. But with these ones, you see it's x to the 4th minus 3x squared minus 4. Okay, so we are going to still be able to solve this using tic-tac-toe, or factor it rather. We'll factor this using tic-tac-toe like we've done before, okay, even though this is x to the 4th and minus 3x squared. Okay, because watch, I'm going to set this up. So right, I have my trinomial x to the 4th, negative 4, negative 3x squared, okay? So when you have x to the 4th here, okay, I know that you could say x to the 3rd times x to the 1st multiplies to get that. But when you factor these, it's always going to be x squared times x squared equals x to the 4th, okay? It's going to keep with that pattern. So that's where you start. Just like we started with the other ones, when it's x squared, it's x times x, right? But then we want to answer, right, what multiplies to get negative 4, and what's going to add to give me this negative 3x squared, okay? And that ends up being negative 4 and positive 1, right? And watch what happens. It's going to be similar, right? When I multiply across, x squared times negative 4 is negative 4x squared, and then x squared times 1 is 1x squared, right? And when I add these up, it does add to give me this negative 3x squared. So it does check out, even though it's x squareds here. So it's the same pattern, and the factor is just the same. Okay. So just know that when you see a trinomial with, instead of being x squared and x to the 1st, it's x to the 4th and x squared, you can factor it the same way. Okay. So that means my 2 groups here are going to be x squared plus 1 and x squared minus 4 equals 0. Okay. And that means I can solve this by taking each group, setting it equal to 0. But just watch, it's going to be a little bit more complex here because of these x squareds. Okay, so x squared plus 1 equals 0, and then x squared minus 4 equals 0. Okay, so look, I'll just do the bottom one first because that's going to be a little bit easier. I would plus 4 to both sides, x squared equals 4, and then when I take the square root of both sides, remember there's that rule that says when I take the square root of both sides, I would need to include the positive and negative version of that answer, okay? Because when I think of like, okay, what would x be if I squared it to equal 4? X could be 2, or it also could be negative 2, right? So x equals positive and negative 2. And remember, with polynomial functions, there's a possibility of real and imaginary solutions, but positive and negative 2 are both 2 real solutions, okay? But then look what happens to this top one. Okay, I would minus 1 to both sides, cancel that. So it'd be x squared equals negative 1. And when I go to take the square root of that, x is going to equal, well, what's the square root of negative 1? The square root of negative 1, right? We can't do the square root of a negative, but that would turn into just I, right? Because that's what square root of negative 1 is equal to. And we would also include positive and negative I because we took the square root of both sides within an equation, okay? So x equals positive and negative I as my answer, and those would obviously be imaginary. Okay, so that's the problem with it, or that's the deal with a problem like that, okay? So you have real and imaginary solutions coming from that, okay? Factoring it the same way with that tic-tac-toe board, okay? So that's the deal with that one. Okay, let me erase because I'm going to go over a couple new rules to help us solve numbers 2 and 3. Okay, guys, so I wrote just some rules here, a new way of factoring. And the official name of it is the sum and difference of cubes, okay? Perfect cubes, okay? And that's what I have in these two equations. I'm going to have perfect cubes that I'm going to be able to factor a particular way, okay? And so look, so it gives you a model here of exactly how these factor. It's really nice because it does factor really well. And there's this acronym called SOAP that helps us with part of it, okay? So look at the similarities here, right? Sometimes you have a cubed plus b cubed. That just means when you have something cubed plus something else cubed, right? Basically, they both need to be perfect cubes, okay? And so when you have this, you don't need to do any work for it. It just factors automatically like this. A plus b, right? So you kind of need to think of, okay, what's the cube root of each of the terms that you have in the group? But a plus b times the group a squared minus a times b plus b squared, okay? So that's what that factors into, okay? And then I want you to look at the similarities between this and this, okay? There's some similarities and some differences, okay? This happens when you subtract, when you have something cubed minus something else cubed, okay? It would turn into the cube root of the first one minus the cube root of the second one. So minus, and then times a squared plus ab plus b squared. So similar, right? They factor almost identical, right? Just the only difference, hopefully you recognize, is the signs. Okay, some of the signs are different. And that's what this acronym SOAP helps you with. It helps you with the signs, okay? Because look, it's a cool acronym. SOAP, easy to remember, okay? So look, when it's a plus in the middle here, okay? The first sign is a plus, the second sign is a minus, the third sign is a plus. Okay, so I'm going to tell you the rule right now. SOAP. SOAP stands for same, opposite, and then always positive. Okay, and again, this is telling you what your signs will be in your factor groups. Okay, so by same, opposite, always positive, what that means is the first sign is going to be the same as the original. So if it's something cubed plus something else cubed, that's also going to be a plus. So same. The second sign is going to be the opposite of what it was in the original. So same, and then opposite. So right, this was a plus, this was a minus. Okay, so second sign is opposite. And then the third sign is always positive. Okay. And why this is a helpful acronym is that it applies to both pluses and when it's a subtraction in the original. Okay, because look, think about that rule. Same, opposite, always positive, right? So if it's a minus in here, the first sign is the same as the original. Same. The second sign is opposite. So opposite of the original. So same, opposite, third sign, always positive. It's positive for both situations. Okay. And if you remember SOAP, otherwise it's the exact same factoring, whether it's a plus or a minus there. Okay. So that acronym plus knowing what these factor groups are is super helpful when you run into problems like these. Okay. So let's just look at these and solve them, and then we'll be all set. So this one says x cubed plus 1 equals 0. Okay. And again, what helps you here is if you know, or might not know, but like if you just have a list of your perfect squares like on the side. And we've done this before. So there's the first 5 of them for reference. 1 is 1 cubed, 2 cubed is 8, 3 cubed 27, 4 cubed 64, and so on. Okay. So it just helps to have those as you do problems like this. Okay, just so you can recognize them. Okay. But if I have this first one, okay, and I still want to follow my rule because I'm solving a polynomial equation, and so that means I want to get all the terms on the same side, and I want the other side to say equals 0. And this one has that, so we're good there, okay? But then what I would do is just go right into factoring this x cubed plus 1, okay? And I'm going to use my SOAP, or sum of difference of cubes factoring, to do that, okay? So I have this a cubed plus b cubed. That's actually what I have here. X cubed would obviously be just x times x times x, or x cubed. And then 1 is technically a perfect cube as well, right? Because that's 1 times 1 times 1. Okay, so if I could rewrite that as 1 or x cubed plus 1 cubed. So I do have a sum of cubes right there. So that means it's going to factor exactly like this. Okay. So in my groups, it's just going to be the first thing plus the second thing. So x plus 1. And then in my second group, it's going to be a squared, or that would be, in this case, x squared, minus, right? Because the signs are going to be the same, and then opposite of the original, so minus instead of plus. So minus a times b, so 1 times x would just be 1x, and then always positive for that last sign, right? And then it would be plus b squared, and b is 1 in this case, so it would just be 1 squared is just 1, okay? So I factored this into my two factor groups, okay? And again, that's so important to do because now I'm going to be able to do okay, and that's important to factor because now we're going to be able to apply that zero product property to solve this, okay? So again, we take each group and we set it equal to 0. So that's x plus 1. Well, actually, I'm going to do that with this group. This second group, I might have to do something else with it, okay? So x plus 1 equals 0. So I get the answer of x equals negative 1. Okay, x equals negative 1. So that would be obviously a real solution because it does not contain a letter I. Okay, now with this second group, okay, x squared minus 1x plus 1, I could try to factor it using my tic-tac-toe board, but I'll save you the time and tell you that would not factor, unfortunately. Okay, so that means I have to go through and yes, if it doesn't factor, your only other option for getting the answers from that group is the quadratic formula. Okay, so again, we have to just say, okay, a equals 1, b equals negative 1, c equals positive 1, and just plug all those numbers in there. Thankfully, these numbers are very small, so it'll make the quadratic formula a little easier, okay? So my formula, my setup would be 1 plus or minus the square root of negative 1 squared minus 4 times 1 all over 2 times 1, okay? Lots of ones, right? And then I would simplify this down, so I would get 1 plus or minus the square root of negative 1 squared is 1, 4 times 1 is 4 over 2, okay? And then I would keep simplifying, so I'll get 1 plus or minus the square root of negative 3 over 2. And again, that negative radical's no good, no bueno. So I want to pull out the I, and I can't simplify that any further because 3 doesn't have any perfect square factors, so I can't simplify it. So I'll just write it as 1 plus or minus I square root of positive 3 over 2, and I actually can't simplify it any further than that, which means that this is an acceptable answer, okay? So this technically is saying two answers, one with a plus there, one with a minus there. So that would be two imaginary solutions to go with this one real solution that I got from the other group, okay? So that's the idea. That's how you would go about solving these, okay? Sometimes this group will work out where you can factor it instead of having to do all this mess, but in that case, we had to do the quadratic formula to get those two imaginary answers, okay? Number 3 says x cubed equals 64, okay? So in this case, again, not all the terms are on the same side, right? So I would want to minus the 64 first, right? So that it becomes x cubed minus 64 equals 0. Okay, so that's a good step one. You always want to do that first. Okay. And now it is a difference of cubes, right? The second one. So I can factor it this way, right? But everywhere you see a b, this is a common mistake. Everywhere you see a b in here, you're not going to put a 64, right? Because what is 64? 64 is 4 cubed, right? It's in my list of perfect. I wrote perfect squares. That should be perfect cubes up there. Yeah, it's a perfect cube, right? Because it's 4 cubed. So where I see a b in here, I'm going to write a 4 instead of a 64. Okay. So this is going to factor into, and right, remember with your sign, same, opposite, always positive. So, right. So it's going to be x minus 4 times x squared plus, right, that sign's opposite, 4, or it would be x times 4, or that would be 4x, right? And then always positive, that last sign. So plus 4 squared, and 4 squared is 16. So that is my groups there, okay? And so again, I would go about solving. So this x minus 4 would give me a real answer of x equals positive 4, right? So we get that from that one. And then, unfortunately, this isn't going to factor either. There's no numbers that you can multiply together to give you a positive 16 that are going to add that give you this positive 4. It's too small. Okay, so that means I have to, yes, do the quadratic formula. A equals 1, B equals 4, C equals 16. Okay, so I have to just go through this, okay, and then plugging it all in. So it would be negative 4 plus or minus big square root of 4 squared minus 4 times 1 times 16 all over 2 times 1. So that's just plugging all those numbers into the quadratic formula, okay? And then you go about reducing it all. So negative 4 plus or minus 4 squared is 16. 4 times 1 times 16 gives you a negative, or yeah, negative 64 over 2 times 1 is 2, okay? And then you subtract, right? So 16 minus 64 ends up giving you 48. Okay, so it'd be negative 4 plus or minus square root of negative 48 over 2. And I'll finish this one out. Okay, I'll just save you from doing all the work. Okay, it ends up being negative 4 plus or minus. You can be able to pull a 4 and an I out of that radical. You're left with the square root of 3 over 2. And that reduces to, you divide those by 2. So your final answer, here's your final answers. It would be negative 2 plus or minus 2i times the square root of 3. And those would be your two imaginary solutions to go with this one real solution. So I know reducing all this, right? We did it earlier in the year with quadratic formula. So don't forget that. Go back and review that if you forget that stuff, because it's a little bit messy. But yeah, the new thing today, factoring with difference and sum of cubes. Hopefully that makes sense. Thank you guys. Have a good one.